this is on exponential growth and decay. You can model growth or decay models by a constant increase or decrease with the following formula. So A of t represents the final amount. A will represent the initial amount. R will represent the rate of increase. And you want to make sure that the rate is always written as a decimal. And then the exponent is the number of time periods. So in this formula, the base of the exponent is going to be 1 plus r if it's a growth, or 1 minus r if it's a decay. Then we also have an exponential function y equals ab to the x. So similar to f of x equals a b to the x, where a is the initial value and b is the constant ratio that you multiply by each successive time. And x will be the time period. Okay, example 1, Clara wants to invest $5,000 into an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000? So when I'm doing an application problem, I like to identify my important pieces. So A is going to represent our initial amount. So A is our initial amount of $5,000. Then we have our interest rate per year. So that R has to be written as a decimal. So what we need to do is we need to move it 2 places to the left. So when we give it to you as a percentage, you move it 2 places to the left. So X will represent, in our function, the number of years. So what we do is we use that information to write our function. So f of x equals a our initial amount, and then we're growing over time, so it's going to be 1 plus r, and then raised to the exponent of time. Now we're going to go ahead and substitute that into our function. So our initial value was $5,000. 1 plus, and then our interest rate as a decimal, 0.0625. And then we raise that to the x power. Now I'm just going to simplify this parentheses. And that's going to be my base. So that is what we call our function. Step 2 says use the graph to predict when the value of the function will reach $10,000. And then use the feature to find the value of t. So what we can do is we can use a graphing calculator. So remember our function up here. I'm just going to change that to what a graphing calculator will look like, or a decimals. Y equals 5,000. And then 1.0625 to the x. And then what we would do is we either use the graphing calculator or decimal. So if you want to go ahead and pause and do that now. And then here are the calculator steps if you wanted to do the graphing calculator. So when we set up our graph, the x-axis will represent the number of years. The y-axis will represent the amount of money. And then we would type that into our graphing calculator or decimals, And this is what our graph is going to look like. Notice that it's increasing over time. I'm just going to put a few numbers in here. So we can use Desmos and click on that, and we can find the y-intercept of over 0 up 5,000. And I'm just going to put a little table here. So this is my x and my y. So my initial value, when the time is 0, so it just starts off, we have $5,000. And then I'm going to click on the number 1. So after 1 year, how much do we have? We have $5,312. So I put 1, $5,312. And I continue that one more time over 2. After 2 years, our investment for Clara is now $5,644. And what we want to do is find out how much or how long will her investment take to reach here $10,000. How long is that? So we would use the calculator and we would find when that y value is at least 10,000. And I'm going to highlight that in purple. So after 12 years, the investment is $10,349. So after 12 years, the investment is $10,349. So we just use the graph to make a prediction of when the investment will reach at least $10,000. So to finish that up, it will take 12 years to reach at least $10,000. All right, here's a second example. The value of a truck purchased new at the dealership is $28,000. What happens when you buy a vehicle? Vehicles depreciate over time, so they decrease. And that decrease rate is 9.5% per year. So we're going to have an exponential decay model. And we want to make a prediction using our graph of when will it fall less than $5,000. So we need to create our function again. So our initial value, our A, is $28,000. Our rate of decrease is 9.5%. So our R as a decimal is 0.095. It's always 2 places to the left. Now we want to write our function. So I'm going to go back to that first part of our lesson right here. And I'm going to highlight it. When we have a decay model, we have to subtract 1 minus R. When we have a growth, it's 1 plus R. All right, so when we write our function here this time, we have f of x. Our initial value is our A, $28,000. And then we have to do 1 minus our R, 0.095 raised to the x. And then what we would do is we would type this into the calculator. And what that will look like is y equals 28,000. And then we would take 1 minus 0.095. Which is 0.905 raised to the x. And that's what we would enter into our calculator. So I did take a snapshot of what the graphing calculator would look like. So here is the image of a graphing calculator. And I'm going to go ahead and label the x-axis. Again, the x-axis represents the number of years that have gone by that he's owned that vehicle. And then the y is the value of the vehicle, how much it's worth. And then we graph our function. We can get many ordered pairs. We can use the graphing calculator. We can use Desmos. So we go up here, and that's kind of a very messy looking graph here. All right, so when the initial value is over 0, up $28,000. And then a year goes by, over 1, up $25,340. And then it decreases, and I'm going to identify after 18 years, the vehicle will be worth $4,643. Now it asks us to find by hand the y-intercept. Well, the y-intercept is this number right here. What we do is we just input 0 into the function, so f of 0, so 28,000.905 raised to the 0 is 28,000, so that's our y-intercept. Our asymptote is just like all of our other ones, right here at y equals 0. If we wanted to find additional points by hand, we could evaluate the function, just like we evaluate it for y of 0, so f of 1. So that's saying after 1 year, what will it be worth? So 28,000.905 raised to the first, we'd use our calculator, and we would get that $25,340. So that would be a point. We wanted to find f of 2 after 2 years. We'd input 2 into the exponent, and what we get is 22,933. So the question says here is, use the graph to predict when the value will fall below 5,000. So I did figure that out on the calculator already, and I labeled it right here. It's this point. So after 18 years, the value of the vehicle will be less than $5,000.